Welcome to the third video of 5 covering straight line theory at higher maths. This video is going to focus on the straight line equation. First lesson intention is going to be a recap of basic straight line equation theory from National 5, and then I'll take you on to some extension work regarding this topic. So, equation of a straight line, y equals mx plus c. What does the y equals mx plus c stand for? Well, m is the gradient of any straight line, which is the steepness, and c is the y-intercept, which means that the line crosses the y-axis at the coordinate 0, c, whatever value c is. So you can see from examples, taking the blue line, it has an equation y equals x plus 3, and it has a y-intercept of 3 and a gradient of 1. Although the 1 isn't shown, it doesn't have to be, but it is a gradient of 1. So basically for every 1 it goes along, it goes up 1. The purple line is y equals minus 2x minus 4, and from our work in gradient, you can see that it is a downward sloping line, so it should have a negative gradient, which it does, and it's slightly steeper than the blue line, obviously in the opposite direction, so it's got a gradient of minus 2 and a y-intercept down at minus 4. The orange line has a gradient of 0.5 to 0.25x, gradient of 0.25, which means it's quite a gentle slope, and you can see that it slopes more gently than the blue line, and has a y-intercept of plus 1. Again, it's interesting to note when you get a straight line crossing through the origin, you have no value for c. It is 0, so you don't need to show it. So equations of that form will just be y equals mx, and in this case, the green line is a negative sloping gradient, so it's minus 0.5x. So y equals minus 0.5x. Horizontal vertical lines are the kind of the different one in the family of equation of straight line, and they don't quite follow the rules of having an equation of the form y equals mx plus c. So if you look at the diagram below and we take the horizontal lines, they will always be of the form y equals the value that or the value of the y-axis that the horizontal line crosses through that. So taking our green example there, what was it? It's an equation of y equals 4. So yes, it does have the y equals part for the equation, but it's just y equals a constant term, and that constant term will be the y coordinate it will always remain at, because it's horizontal. Purple example of a horizontal line there is simply y equals minus 3. Now, vertical lines, they're slightly different. They really are the completely different equation compared to all the others, in that they make no mention of the letter y, and are just simply x equals the value of the x coordinate that it always remains at, or basically the value of the x-intercept which the vertical line will go through. In this case, looking at the orange line, it's x equals 2, so it remains at an x coordinate of 2, so therefore its equation is simply known as x equals 2. And the red line, it carries through and cuts through at minus 5, x equals minus 5, so its equation is simply x equals minus 5. Always be aware of that, as questions within the higher course will use scenarios where the straight line you're dealing with, or the equation you're trying to find the straight line for, is horizontal or vertical. Now, some examples for you to try finding the equation. These ones you should be given the y-intercept either diagrammatically or by coordinate. From this example 1, we find the gradient. That just means selecting 2 suitable coordinates. It's any coordinate that lies on the line. In this example, I've chosen 0, 2, and 2, 4. Subbing them into the gradient formula, I get a gradient of 1, which is as expected because I'm going along 1 and up 1, and it's a positive gradient. Our y-intercept in this case is 2, so we just identify it and we just write the equation as y equals 1x plus 2. You can write it as, y equals x plus 2. You don't have to have the 1. An example. In this example, you're not free to pick the coordinates. You're given 2, one of which is the y-intercept. So again, that allows us to find c. But we find the gradient first, which is, in this occasion is a fraction. We sub both that and the y-intercept of 6 in, and we get a straight line equation of y equals 3/4 x plus 6. Now, I want to do a recap on Ye Old Faithful. For those of you that have had me as your teacher, I refer to y minus b equals m bracket x minus a as Ye Old Faithful, because in any straight line, finding the equation, it will nearly always be that you return to in order to find the equation. So I refer to it as Ye Old Faithful as a kind of wee funny, silly name to hopefully help you remember it. So if the gradient m and one coordinate AB, so that's just a generic example of a coordinate, is known for a line, we can always get the equation for that line using y minus b equals m bracket x minus a. And that's what I refer to as U faithful. As I've said before, you must know the gradient and a coordinate, and it's always very useful to use the U faithful when the y-intercept is not given, either diagrammatically or as a coordinate, which will predominantly be the situation you'll have to deal with at higher. And remember, to use it, you must know the gradient in one coordinate. Can't be used otherwise. Just to explain where it comes from, it's not just something that we've kind of plucked out of thin air. If you take the gradient theory between two coordinates, one xy, one ab, which are obviously always changing, depending on the straight line involved, you sub those in and then rearrange, you're able to create y minus b equals m bracket x minus a. And y and x just represent all the coordinates that lie in the line, and AB just represents a coordinate you know. And that's where the formula comes from. Now, example to try. Simply in this one, you just sub in the gradient for m and 4 minus 1 in for a and b. When you do that, watch out. Again, double negatives can be problematic in this sort of question. So just pay attention, make sure you don't get caught out by that. When we do the multiplying out of the bracket, once again, watch out that you make sure you multiply the minus 4. Common errors, even from those able pupils, are forgetting to multiply a bracket out successfully, i.e. forgetting the second term. In this one, your last step is to bring the plus 1 over to join the other coefficient of minus 12. So when you subtract it across, it becomes y equals 3x minus 13. Second example. This example is identical to example 1, but has been chosen because the gradient's an example of a fractional gradient, which you've got to be, again, at higher comfortable with, as it will be quite a regular occurrence. Subbing in EO faithful, replace the b with 5, replace the m with 3/4, and replace the a with minus 2. Watch out for the double negative. At this point, now, this is very context dependent, but since they just want the equation, whatever form the equation you give it in is actually reasonable. So you don't have to give it in y equals mx plus c form. You can give it in a more suitable. And in this occasion, more suitable would be to multiply out the divide by 4 part to get rid of the fraction. It makes life easier if you're not dealing with fractions, because they do have a tendency to be areas where mistakes are made. So if I multiply the 4 out on the right-hand side, I have to multiply all the terms on the left-hand side by 4, which gives me 4y minus 20 equals 3 bracket x plus 2. Multiplying out that, gathering the like terms, leads to 4y equals 3x plus 26. So again, if the question doesn't stipulate, you're more than within your rights to give the equation in that form, which has removed any, versions of the fraction. Again, if you choose to not go down that route and use the fractions, you're absolutely within your rights. So a final answer of y equals 3/4 x plus 26 over 4 is absolutely within your rights to do. So again, don't be scared to approach it whatever way suits you. If you're comfortable using the fractions, feel free to do so. Example 3, just where they give you 2 points, find the gradient for that 2 points is 2. In EO faithful, it doesn't matter which coordinate you use. As long as the coordinate lies on the line, it will work and will work itself out to the right equation. So in the first example here, I choose the coordinate 2, 9, sub it in with the gradient of 2 that we worked out, and therefore rearrange to get y equals 2x plus 5. Just to show you, if I'd chosen the other coordinate, it gives the same result of minus 2, 1. Subbing in the minus 2, 1. Again, watch out for the double negatives. Rearranging, I get y equals 2x plus 5, which is the same as above. So it is open to whatever coordinate you want to use, as long as that coordinate lies in the line for which you're trying to find the equation. Next learning attention. I want to do a quick recap of the general form for a linear equation and how to rearrange it into y equals mx plus c form. Again, this is a National 5 skill, so should be more of a recap than something unfamiliar. The general form for a linear equation is where every term has been shifted over to the left-hand side and it's equal to 0. It's quite rare to use the general form, but again, just be aware of it. At this one, all non-zero terms are on the left-hand side. In the general form, you can't read the gradient y-intercept for the straight line without doing some form of mathematical manipulation. So again, it's not that useful, but there are times where it may be applicable to have it in that form, or the question starts out by giving you it in that form. So just be aware. So being able to rearrange it into y equals mx plus c form is a useful skill because it allows us to read the gradient or the y-intercept, which given bigger questions, bigger topics may be very useful to be able to do. So example to try. Find the gradient of the line and find the coordinates the line cuts the y-axis at. Right, first one is just simply make it y equals. So you bring all the non-y terms over to the right-hand side. So plus the 3x, subtract the 9, then divide out the 4 because it's 1y. We want y equals mx plus c. So we divide out the 4 and you get 3/4 x minus 9/4. And that means the gradient is 3/4. So once it was in that form, I'm able to tell you the gradient. For B, find the coordinates the line cuts the y-axis at. Well, the y-axis is your y-intercept, so it's just minus 9/4 is the y-coordinate, so the y-intercept is therefore 0, comma, minus 9/4. You can be asked to determine where a line crosses the x-axis as part of a question like that. To do this, you simply replace y with 0, because when it's crossing the x-axis, your y is 0. Y is always 0 when you cross the x-axis, no matter what type of equation you're dealing with. Now, to determine the gradient and coordinates for the y and x-intercepts for the equation minus 2x plus 4y plus 16 equals 0. So again, first step is to rearrange into y equals format to get the gradient. So that means gathering all, non-y terms over to the right-hand side. In this equation, it leads to 4y equals 2x minus 16. Divide out the 4 to get 1y, and therefore we have y equals a half x minus 4, leading to a gradient of a half. That also allows us to find the y-intercept y-coordinate, which in this case leads to the y-coordinate being 0 minus 4. Again, read from the rearranged equation. Now, as I mentioned above in the lines above, to find an x-intercept, you set y equal to 0. So that's just take your equation, replace the x value by 0, the y value by 0, and then rearrange to make x the subject. And when you do this, it turns out x is equal to 8. So therefore, the coordinate is 8, 0. Straight line equations can be written in other forms, like 2x plus 3y equals 4. So it's not the general form or standard, that we can also rearrange into y equals mx plus c form. Example to try. First one, all that's different here is not everything is on the left-hand side and not everything's on the right. So your job is to get y again on its own equal to everything on the right-hand side. So shifting the 6x, shifting the 3 in front of the y by dividing it out leads to the equation of y equals minus 2x plus 3, which gives us a gradient of minus 2 and a y-intercept of 3. Doing it for the second one, plus the 3x over, divide through by the minus 12. Again, be prepared for fractional answers, which must be given in the simplest form within higher. So it's 1/4 x plus 2, which gives a gradient of a quarter and a y-intercept of 2. Third example, just funny forms where maybe x is the subject or 4x is the subject. Again, you've just got to rearrange. Now, your options here are plenty. You could keep the y where it is and shift the 5 times it out. It's up to you. If you want to make y the subject by shifting it over, feel free. But again, you don't have to. You're free to kind of do it as long as you get to y equals, even if the y is on the right and everything's on the left, you can just swap that around. At this point, multiply out the 3 and then divide it by the minus 2. You should have got to a final solution of 6x minus 15 over 2, giving a gradient. Watch out, minus 15 divided by minus 2 leads to a positive answer. So it's plus 15 over 2, not negative 15 over 2. At this point, that gives a gradient of 6 and a y-intercept of 15 over 2, which again, you can give as a decimal, but I would get in the habit of giving things as fractions, unless the context really lends itself to a decimal. Now, some equations using yield faithful may be given in a different form. They want you to find the equation of the line through 2 minus 3 parallel to the line with equation x minus 3y minus 9 equals 0. Right, the key thing here is element is the word parallel. If it's parallel, it means it shares the same gradient. Therefore, we need to get the gradient of the line x minus 3y minus 9 equals 0. So that will involve rearranging it. So hence why I'm testing your rearrangement skills. At this point, it comes out as y equals 1/3 x minus 3. So therefore, the gradient of the new line that they want us to find is 1/3 as well. So use this gradient one coordinate with the yield faithful. So you sub in the 1/3 and the 2 minus 3 into yield faithful. Watch for double negatives. Again, I would multiply the fraction out, given that we aren't being asked to do anything in the context of higher. questions like this are likely to be part of something bigger, which may also end up being intersecting lines. So sometimes it is easier to not multiply it out and leave it as y equals. But here I've chosen to multiply it out. Make sure you multiply both the y and the minus 3. And when the minus 3 combines with the minus and the times, it becomes plus 9. Take over the 9 to the other side, so it becomes 3y equals x minus 11. Example 5 is taken from the 2016 New Hire paper, question 1. So it's in a straight line equation that's not in its standard form and is parallel to the line with equation y plus 4x equals 7. So using the rearrangement technique, so we get the same gradient, because we're going to use the fact that it's parallel. Again, the fact that it's 2 marks and the fact I mentioned parallel are the kind of key trigger phrases and value that kind of gives me an idea. This is quite a straightforward question. So we then take the minus 4, sub it in the yield faithful, and we would have got y equals minus 4x minus 5. Be aware, you've probably only getting a mark for knowing they're parallel and therefore having the same gradient, and a second mark for completing the yield faithful. So the amount of marks in higher are less generous for work that you would have got more marks in National 5, because they're now assuming this is a prerequisite skill, something you are able to do, so aren't rewarded in the same way you would have been at National 5. Apologies about that wee bit at the bottom. That'll make sense, but this is taken from the New Hire Spaceman paper. So the equation is line L1 has equation is root 3y minus x equals 0. Line L2 is perpendicular to L1. Find the gradient of L2. The key word in that one is going to be perpendicular. If it's perpendicular, it means we can use the fact already on the screen below, m1 times m2 equals minus 1 for perp lines to find the, L2's gradient. So rearranging the form that we can read its gradient, that means getting y equals, so we have to remove anything around it, which means we have to move the root 3, so we divide out by root 3. So y equals x over root 3, which gives us line 1's gradient of 1 over root 3. Doing our flip it, change its sign, it becomes minus root 3 for the gradient for L2. That's all we've been asked, the 2 marks. So the first mark is for getting it into y equals form. The second mark is for using your knowledge about perpendicular gradients. Part B, calculate the angle. Angle and straight line or gradient theory should be triggering in your head the tan theta. So in this one, we're going to use tan theta, m2 equals tan x. And if tan x equals minus root 3, our related angle will be the tan to the minus 1 of root 3. The key element, again, we've dropped a negative. We will take account of the negative in our cast diagram. We are looking for the quadrants A and S. We ignore cos and tan because the angle can't be bigger than 180. So we're looking for where tan is negative. That is in the sine quadrant. So therefore, we're doing 180 minus 60. It was taken from paper 1. So again, using the the exact value triangles to get what root 3 was. Turns out 60. So we're doing 180 minus 60. So we should have had an angle to the positive direction of the x-axis of 120. So that's a good skill. That's combining our tan theta knowledge, it's combining our knowledge of perpendicular gradients, and it's combining our knowledge of rearranging into y equals mx plus c form where appropriate. Another wee area with kind of straight line theory is I want you to understand how and be able to check if a coordinate lies on a line. It's just a test. Some of the questions are for maybe a mark. We'll ask, does this coordinate lie in the line you found? So to check if a point is on a line, you simply substitute the coordinate into the equation and make sure the left-hand side equals the right. So there's an example to try. So it says determine if 1, 3, and 3, 5 lie in the line y equals 2x plus 1. So simply sub the coordinate in, so replace your x with 1 and your y with 3, and check left-hand side equals right. If left equals right, you can make a statement, since 3 equals 3, 1, 3 must lie in the line. 7 and 3, 5. That gives me y equals 2x plus 1, which gives me 5 equals 2 times 3 plus 1, which gives me 5 equaling 7. That is not mathematically true. So since 5 does not equal 7, 3 and 5 must not lie in the line. Key to note, the equation does not need to be in y equals mx plus c form to test if a point lies in the line. It can be in any form, as long as it's a linear equation for this type of question. You can just simply sub the point in. As long as left equals right, then it does lie in it. If left does not, it doesn't. So here's another example in the equation 6x minus 3y equals minus 36. Subbing the point in, doing the calculation, the number crunching, minus 36 does equal minus 36, so therefore minus 36 must lie in the line. Subbing in 0, 0, that leads to nothing equaling minus 36, which is not the case. So therefore, 0, 0 must not lie on the line. You could kind of tell 0, 0 wouldn't lie on the line because the equation above, if you rearrange it, would have a y-intercept. For it to lie in 0, 0, it wouldn't. But again, the proof is by subbing it in.